Hey, Year 11. So let's start with the very first topic of the year, and this is lessons 1 and 2 um, on approximations, decimal places, and significant figures. These are the questions here that you need to do to complete this exercise, as well as the practice questions, which you will find throughout this lesson note. So these are the practice questions here. I'll leave them blank for you guys to work on. So here are also practice questions. But let's make a start straight away and let's go straight into approximating numbers. This is nothing really new to you guys. Well, this is basically rounding. Okay, so we're either rounding to 3 decimal places or 2 decimal places or 1 decimal place or as many decimal places as the question suggests. So the rules for rounding is to look at the value of the digit to the right of the specified digit. So what does that mean? So you might have your own way of rounding, but if I'm to look at this example here, the way I'll go about this is I say, okay, if this one says to 3 decimal places, then what we are expected to do is count. This is 1, 2, and the third decimal place. We point to the third decimal place and then we circle the number after. If the value circled is a number that's 5 or bigger, then we round up. If it is 0 to 4, then we leave the digit unchanged. So in this case, we would get the number that we've circled is a 4, so it's in a small group. So the number that we've pointed to stays the same. So 3 decimal places would be 1.533. With this one as well, if we want to round to 3 decimal places, we point to the third decimal place and circle the number after. So because the number that we've circled is a number that's 5 or bigger, we're going to round up, which means the number that we've pointed to, which is the 7, goes up to an 8. 8.458. And the same rule applies for when we're rounding to the nearest, whole number, for example, the nearest 1,000. Now you need to know which numbers belong to which column. So this number here is the ones column. This is the tens column, the hundreds column, the thousands column, the tens of thousands column, and so on. So if we're rounding to the nearest 1,000, what we're going to do is we're going to point to the thousands column and circle the number after. Because this number that we've circled is a big number, the number that we're pointing to goes up. So we get 35,000. This one here, again to the nearest 1,000, we point to this number here. We circle the number after. Because it's a small number, we keep it the same and the rest become zeros. Now, just a question, if we had another number, for example, 39,865, and we wanted to do this to the nearest 1,000, same thing again, we point to thousands column, we circle the number after. So what happens now? Okay, so the number we circled is an 8, which means it's a big number, which means the 9 that we've pointed to goes up. But you can't go any higher than a 9 for a single digit. So what we now need to do is instead of making that 9 go higher, we're going to make these two numbers go to a 40. So 40 and then 0, 0, 0. That is rounding to the nearest 1,000. So have a go at the practice questions underneath. But let's now move into something that's new for you guys, which is called scientific notation. So when we work with really large or really small numbers, often we use scientific notation to help us, keep it short and condensed. So sometimes on your calculator, you'll see that you get these really weird symbols when you have a really big number. This is what we're going to try and understand. To write a number in scientific notation, we express it as a number between 1 and 10, and then multiply it by a power of 10. And you'll see what we mean in these examples here. So the first question asks us to write 7.8 million in scientific notation. So what we want to do, that when the number is 10 or bigger, so this is a big number, it's bigger than 10, the decimal point has to move to the left until you create a number that is between 1 and 10. So let's just write down the number, 7,800,000 So whenever we have a number like this, the decimal point is at the end, right? Because, it's always at the end unless there was a decimal point in here somewhere, which there's not. So we want to move the decimal point to the left until we make a number that is between 1 and 10. So we move it once, twice, 3, 4, 5, 6. We want to move it in here because if we move the decimal point here, what we're going to get is a number 7.8. Okay, that is a number between 1 and 10. So we've moved it to the left 6 times. So what we're going to do now underneath is we're going to write, okay, 7.8, because that's the number that we created between 1 and 10, and multiply that with 10, always 10. But the number that goes as a power here depends on how many times you move the decimal. We move the decimal 1, 2, 3, 4, 5, 6 times. So we're going to put the power of 6 up here. That's all we need to do. We just converted 7.8 million into a scientific number. Let's see what happens when we want to make a really small number into a scientific number. Let's just rewrite the number down again. Make sure we're writing the correct amount of zeros. Okay, now this time we want to move the decimal to the right, so that way we can create a number that is between 1 and 10. Because right now we have a number that's just a little bit bigger than 0. So we're going to move it 1, 2, 3, 4, 5, 6, 7. We just created the number 5, okay, because 5 and a decimal point is like the same as saying 5.0, which is a number between 1 and 10. So we created the number 5, and we want to multiply that with 10. Now the power, we moved it how many times? 1, 2, 3, 4, 5, 6, 7 times. But instead of just putting a 7 up here, we're going to put -7. As you'll notice here in the notes, when you move to the left, the power is positive, and when you move to the right, the power is negative. This is something that I would highly recommend when you make your summary book, that you put these sort of notes in, because it's following a rule, I guess. Let's do that again with 2 different numbers. Let's just do the exact same thing again. So let's write down 49000. Oops. I'm just going to space it out so I know exactly how many to put down, because it's easy to make a mistake here. Now right now the decimal's at the end because it's a really big number. So I'm going to move it until I get to make a number that's between 1 and 10, which would be 4.9. So let's write down 4.9, multiply it with 10. Now how many times do we move to the left? 9 times. And because we move to the left, the power on top is positive. Left, positive. Let's do another example here. 0 points. Let's make a number between 1 and 10. We want to stop right here because we want to make 4.2. Now, let's write 4.2 times it by 10. How many times do we move to the right? 1, 2, 3, 4, 5, 6, 7, 8. So 8 times to the right, but because we move to the right, it becomes a negative number. Just want to make note of something. When you're doing this, and let's just say we have a different question. Let's say we had 0.00842331. Okay, that's we haven't got a number between 1 and 10 here, so we need to move it to the right. We move it just here. Okay, you don't need to copy this down, but we move it here because what we're going to do here is we're going to create a number between 1 and 10. So the number that we create is 8.4231 times it by 10. And how many times do we move the decimal? 1, 2, 3. So that would be your answer for that question. Okay, now a lot of people just think, yeah, all right, keep going until you get to here because we just want 3.1. But no, you move it until you get your first number that is between 1 and 10, and that would be 8.4231. So if you want to copy that down, you can, but it's not needed. Now we're going to learn how to do the opposite. So how do we go from scientific notation to a basic numeral? So how do we do that? Basically, what we need to do is this thing here is basically the same thing as saying 3.576 times 10 to the power of 7 means that the decimal point needs to be moved 7 places. So that positive 7 up there means that the decimal place needs to be moved 7 places. Hopefully you can write that a lot neater than I did. 7 places to the right. Now try to ignore any of the rules from the previous examples. These are 2 different questions, so we might have 2 different rules. But I'm just trying to make this as simple as possible if you get a question like this. So what you can do is you can start off by writing this number here. So let's write down 3.576. And then what you want to do is you want to move this decimal 7 places to the right. So 1, 2, 3, 4, 5, 6, 7. Here it says zeros need to be added as placeholders. So everything underneath that doesn't have a number will be a 0. So your new number is, which is the basic normal number, 3, 5, 7, 6, and then 4 zeros. Just to make it easier for the person to read, put your commas where you need to, every 3 digits. So now I know that that is 35,760,000. Let's say we have the same question, but now we have a number with a negative power. Okay, what do we do then? Okay, multiplying by 7.9 by 10 to the negative 5 means that the decimal point needs to be moved 5 places, it's a bit neater, to the left. Okay, so what I'm going to do is I'm going to write down 7.9, then I'm going to move it 5 places to the left. 1, 2, 3, 4, 5. Underneath those gaps, I'm going to put zeros. Now, this is a very, very common mistake. A lot of my students in the past have just put zeros underneath those little loops because it just makes sense. But here, what you don't understand is that we've got points, because we've moved the decimal point here, we've got points 0.00079. Now that's fine if you leave it like that, but what we probably prefer to see is that we have that extra 0 there, okay, because it's 0.0000079. Just keep that in mind for when you're doing questions like this where you're moving it to the left, because usually that's what will happen. Cool, so then you get some practice questions here to write numbers into scientific notation and then back out of scientific notation. This is the second part of the lesson, and this is significant figures. Okay, so these are basically types of numbers that you're going to need to know for all of this year and all of next year. I'm just going to go back to the very front page for a second. Obviously, it's important to know these things, these questions here, because it doesn't matter what question you're going to get this whole year, you're probably going to be asked to round 2 decimal places, 3 decimal places, 4, depends on what the question says. You might even be asked to round to the nearest 1,000 or to the nearest 10 or whatever it is. Okay, so these questions are super, super important, right? But in general maths, we also are expected sometimes to be asked questions to round numbers to significant figures. And that's why it's very, very important you get this right from the start of the year. So that way you know in the next couple of topics, in the rest of the topics for the year, how to round to significant figures. But this is something new to you all, and we're going to introduce this. So let's get straight into it. So there are some rules that you need to know about significant figures. That the first and most important rule is that the first non-zero digit, so any digit that's not a zero, reading from left to right, is the first significant figure. Okay, so here we have, these are all non-zero digits. Okay, every non-zero digit is a significant figure. This is not a zero, this is not a zero, and this is not a zero. Therefore, we have 3 significant figures. This is not a zero, this is not a zero, and so on. Therefore, we have 4 significant figures. It's probably the easiest one. All zeros between 2 non-zero digits are significant. Okay, so this is a non-zero and this is a non-zero. So they're significant. But all zeros in between, like a sandwich, also counts as significant. So here we have 3 significant figures, and here we have 4 significant figures. Okay, because these zeros are sandwiched by 2 non-zeros. If we do not have a decimal point, the zeros to the right of a non-zero are not significant. Okay, so this is an important one. This is a significant number, but these numbers here are not significant. Okay, because this is not a decimal number. This is just a normal 500. So the first number is significant, and the trailing zeros are not significant. So that's why we only have 1 significant figure. Same thing with this one. The first one's significant, and the rest are not. Again, only 1 significant figure. If a number starts with a non-zero, so like starts with a 1, starts with a 2, starts with a 5, and it is a decimal number, like this, all digits are significant. Okay, so 100. Now, typically, these 2 numbers here would not have been significant, but because we have a decimal point here, and 3 zeros to follow, well, then we have 6 significant figures. Same thing here. Our first number is non-zero, so it's a 2. This is sandwiched by the other 2 non-zeros, so this also counts. But then we have a decimal point here, so the rest of these numbers are significant. Same thing with this one. Although we don't have any numbers after the decimal point, we know that there is a decimal point, and so all 3 count as significant. We're going to practice this a lot, so it might be very, very confusing and annoying right now, but with practice, we will get the best out of this. If a number is less than 1, so it's basically a 0 point something, count the digits from the first non-zero digit. This is how many significant figures you have. Okay, this is a number less than 1. Okay, it's 0 point, 0 point, 0 point. Here we're going to count from our first non-zero. So we have 2 significant figures, 3 significant figures, 4 significant figures. Now that 0 counts. Okay, it's the trailing numbers after the first non-zero. And same with these 5. So let's use some of the rules to determine how many significant figures we have in the following numbers. Okay, so let's have a look. Here, all these numbers are non-zeros, so we have 5 significant figures. Here, this is basically the same as the rule up here. If we do not have a decimal point, our first number is significant and the rest of the zeros are not. So we only have 1 significant figure. Here it says if we have our number that starts with less than 1, so 0 point something, then our first significant figures are the first non-zeros. So it's just these 2 significant figures. I'm just going to underline the numbers that are significant. Same thing here. These 3 are significant. Same thing. New rule here. So if any 0 that's in between 2 non-zeros is significant. So we have 4 significant figures. Same thing here. This 0 is sandwiched between these 2. So we have 3 significant figures. All right, and now because we have a decimal point, 0.0, we know that all numbers are significant. So we have 4 significant figures. The reason why we learn all this is because you're going to get asked to round numbers to significant figures. So round this number here to 4 significant figures. Round it to 3, round it to 2, and so on. So let's do that together. So how many significant figures? First and foremost, before you can do any rounding, you need to know how many significant figures we have, and perhaps it's a good idea to underline the significant figures. Here, these numbers are these numbers here are our significant figures. So we have 1, 2, 3, 4, 5. Okay, so let's now round to 4 significant figures. For 4 significant figures, start counting our 4 non-zero numbers from the left, or basically the fourth significant figure. Here is our first one, here is our second one, here is our third one, and this is our fourth one. So we point to the 3 and we circle the number after. The next number 5 is a big number, so we round up. So the number that we've pointed to now becomes a 4. Okay, now that should be already in your book. But we're going to now do the same thing for 3 significant figures. Okay, so what I'm going to do is I'm going to write the whole number 0.0064735. Okay, so if we want to round to 3 significant figures, what we want to do is we want to underline all the numbers that are significant. So we know that these are these ones here. They're all significant. So we want to round to 3 significant figures. So we're going to point to the third one, circle the one after. The next number is a 3, so it's a small number. So what we do is we round down. So all we're going to do is we're going to write 0.0064 and then keep the 7 as is. This is 3 significant figures. Let's do the same thing again. Let's write the number down. 0.0064735. Let's underline all the significant numbers, which is here. We want 1 significant figure, so we're going to point to the first significant figure and circle the number after. The next number is a 4, which is a small number, so we round down. This 6 here stays the same. So we have 0.006, and that is rounding to 1 significant figure. Let's do the same thing here with sort of like a big number, a number that's bigger than 10. First of all, how many significant figures do we have? Well, it's a decimal number and they're all pretty much non-zeros apart from this one, which is sandwiched by 2 non-zeros. So all of them are significant. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 significant figures. Let's round it to 2 significant figures now. All right, so the 2 significant figures, start counting and point to the second significant figure, which is here, and then circle the one after it, which is here. This is a 7, so it's a big number. So this 3 now becomes, it goes up and goes to a 4, 94. Let's do the same thing. 93.738095. We want to round to 1 significant figure, so let's underline all the significant figures, even though it doesn't really make that much of a difference. It's a good habit to be in. Point to the first significant figure and circle the number afterwards. It's a small number, so we round down. Now, this number here, 9, stays the same. Now, this is a tricky part. Some people will just leave it as a 9 because they're following the instructions. But we want this to be, all the numbers after, to be zeroed. Okay, so 90. And don't forget there's a decimal point here. The reason why we keep this now as 90, even though we said 1 significant figure, is because if you think about it, this only really is one significant figure. This 0 does not count as a significant figure. Our 9 is the only significant figure here. But if you change this just to a 9, well, you're completely changing the number. You're like dropping from 93 all the way down to 9. So it makes sense to keep it as 90, and you still got one significant figure. This would probably be the hardest type of question you get from significant figure roundings. Let's write down the number again. What is it? 93.738. 095. All right. We want to round these to 5 significant figures. Let's underline all the significant figures. Point to the 5th one. Circle the one after. So the number 0 is a small number, so we round down. So basically our number will be 93.738. And that is rounding to significant figures. So this video here covers you for the lessons 1 and 2 questions. What I want you guys to do is first complete the practice questions and then go straight into exercise 10A questions, which directly relate to these notes. So good luck and thank you very much.